जिंदगी जीने का मकसद खास होना चाहिए, खुद पर विश्वास होना चाहिए। जिंदगी में खुशी कभी कम नहीं होगी बस, जिंदगी में खुशी कभी कम नहीं होगी बस, खुशियां मनाने का अंदाज होना चाहिए। Good morning to one and all present here. I am Aryan Chauhan, and as we gather in unity and spirit, I welcome the brand new day with our open hearts. Let's step into the world of learning and discovery as we commence today's seminar. We have a great lineup of activities and speakers planned for today. The objective of this seminar is to provide you with an opportunity to learn more about our topic, wastewater management, from various perspectives and sources. Today, we come together to share ideas, learn from one another, and build new connections that will help us grow both professionally as well as personally. I would also like to acknowledge that the presence of our distinguished speaker, Dr. Santosh Yadav sir, who have kindly agreed to share their expertise and knowledge on urban and industrial wastewater treatment and conservation, including reuse and recycle. Dr. Santosh Yadav sir, he is a Counsellor, CII-ITC, Center of Excellence for Sustainable Development, New Delhi. He is CII-certified Sustainability Assessor in the year 2022-23. He has 18 years of experience in environmental services industry. He has his expertise in project management, sustainable development, environmental policy advocacy, ESG, EIA, EMP, solid waste management, bioremediation, wastewater treatment, biodiversity, and environmental auditing. He has 15 publications in peer-reviewed journals and 3 book chapters, 20 conference proceedings, and 40 project reports. He is a reviewer and committee member in journals, conference, and institute. He has worked in various national organizations as environmental scientist. He has also done his PhD in environmental science, CSIR NEERI. Thank you, sir, for joining us today. We hope you will have a great time and leave here with new knowledge, ideas, and connections for us. With equal pleasure, I invite Dr. Santosh Yadav sir on the stage. Thank you.
Thank you. Okay. This side? Okay. Okay. ठीक है. So good morning to all, and thank you for the very nice introduction about me. I was not able to say about what I did and what are the expertise of mine. So thank you again, and thank you for the inviting me. And it's really pleasure to be here. So today we will discuss about this topic called the urban and industrial wastewater treatment, conservation, including reuse and recycle. So the topic is very broad, I would say. It's a one-day session is not enough to cover all those parts. So what we will discuss before going to the exact topic, wastewater treatment, conservation, reuse and recycle, we will understand background of this. Why we are discussing this wastewater treatment and its conservation. Why? Because we know that there is a pollution everywhere, wastewater pollution. Every day we see around us. So, when you pass somewhere and you see that there is some nala passing through and it's smelling. And then we start thinking about that, these are some concern we have to thought. But no one will be willing to do that. So we have institutions called the Govt of India, state governments, and the municipalities. So their responsibility to deal with this kind of issue and keep aware to the public about the the pollution part. So before going to that, the policies part we will discuss a little bit. Might be you have gone through that in the last 5 days. It could be boring for you. What we are discussing every time, the pollution and the same thing and all those. But we will go through the little bit about the policy part. So, is anyone know about the difference between different kind of policies? So, what is act, what is rules, what is guidelines, and who made it. So if anyone can tell me about that, what is act and what is rules, and what are the difference between acts and rules? Anyone? Have you gone through that or thought about that? No one. No problem. This is the time. Even I didn't know that. I used to think about that. Act and rules are the same. Just people say like that, acts and rules, and then when I grown with the subject, I realized there is a differences. So act, how act makes policy? Who is the person makes the policy? Our parliament and our state government, that state assembly departments, or the what we say, Vidhan Sabha, something like that, and the Parliament of India, Sansad jo hai, they prepared the act. So before making the act, the bills form, like the bills they draft based on the consulting stakeholder inputs, like this. Who are the stakeholders? So let's understand who are the stakeholders for the any policy. Stakeholders who is going to affect by those policies, those rules, those are the stakeholders. Some are the direct stakeholders and some are the indirect stakeholders. So direct stakeholders, it means if we are going to make some policy with respect to the water disposal, and who are the stakeholders? Every individuals. We use the water, we are disposing the water. So we are the stakeholders. Industry, they are using the water, they are making it, they do the process and then they dispose it. They are the stakeholders. So based on the stakeholders input, our parliament, they made the policy first in the form of bills. It's called the bills. We used to heard about that. Parliament, they have put the bill and they are discussing on that, they are going to come out with the policy. If you guys are aware about the environment rules and regulation, I think most of you are the civil engineers, but try to involve the background, and then you will be engineer, and then you can deliver the better way if you know the background. So today or yesterday, I think Government of India in the Parliament, they have placed the Forest Conservation Bill, and that bill is, they are going to discuss it based on the inputs received from all the stakeholders. In that, the state government is also a stakeholder for the bill. They have put their representations. The industry, they have put their representations. All the I would say NGOs, they have put their representation. Everyone, mainly the tribal peoples, because the forest, basically most of the tribal people, they live in the forest, so they have put their representation. Based on that, they are going to discuss, and then we will have a new rules called the Forest Conservation Rules. Not rules, sorry, Act. So once the bill discussed and it's passed in the Parliament, it signed by the President, it's convert into the same bill will be convert into the Act. So bills, Act. The Act, after Act, what we have to do it with that? Who is the responsible and who is the person who is going to deal with the Act? Ministry. Now the ministry roles comes. Whatever the Act comes, the relevant ministry. For an example, Forest Conservation Bill, or now we are here, we can say that the Water Prevention and Control of Pollution Act 1974. It was passed by the Parliament, and Act, Ministry of Environment and Forest and Climate Change are the responsible ministry. They have to work on the Act. How they will work in the Act? Based on the Act, implementation of the Act comes the rules. The understanding of this Act is there. How to implement the Act, we have a rules. And then the other departments linked to the ministry, they can make the guideline, notification, so many things. But this is the flow. So rules and Act are the different. Acts are the parent organization to define a well way, to understand the people, to implement, to work. Rules comes. So we have these rules. Act about the water protection and prevention and all those. Way back like 1974, the first, the Government of India thought about that and they have come out with a act. And then it had several amendments. We have an Environment Protection Act 1986 it's called the Umbrella Act. Like whatever you think about the environment, you can go and get it, then help from that EPA Act, and you can get the result. To help and implement that act and the prevention and pollution of the water, the Government of India has started several initiatives. It's a way back the Government of India is working on this pollution reduction and management of the water and all those things. I have listed here the 2-3 recent activity the government has started, like the Swachh Bharat Mission. It's a very famous program, I would say. In the last 5 to 8 years, this program is running across the country, and many celebrities, they are promoting it. We have to Swachh Bharat mission, and we are paying for that. Now the GST has come. Before GST, whatever we used to buy, we used to see that there is a Swachh Bharat tax is there. So we are paying for that. So we have a right to fulfill. And then the last 5 years, the Prime Minister announced about that open defecation free, like that Har Ghar toilet, something like that. They have come out with a plan. Amrit for the mission for the city and all those waste management. So these are the initiatives Government of India started. Who are the organizations, particularly with respect to the wastewater they are working, and their responsibility to implement the prevention and pollution part of the water. So first is the MOHUA. We call the MOHUA short form, Ministry of Housing and Urban Affairs. So they are the national level. Their responsibility to implement the plan. Whatever we see around us, the water treatment plant, wastewater treatment plant, or water conservation plan, all the infrastructure development and its operation is deals by this ministry. They have a state level and the city level, like the mayor and our ULB, they are the corporation, municipal corporation, they comes under that. Then we have a Ministry of Environment, Forest and the Climate Change. They makes the rules, particularly what are the limit for the disposal, what are the limits for the emission and all those parts. So they are the kind of regulators, licensing organizations. They work through the Central Pollution Control Board, then we have a State Pollution Control Board, then we have a regional or the regional and the district pollution control boards. Also Ministry of Water Resources and River Development and Ganga Regeneration Ministry. They are working to protect and they have invested the very good management, good amount of money for the development of protection of the river Ganga. So around the river Ganga and Yamuna, several infrastructure developments are going on to whatever the waste is coming to the Ganga, that should be stopped somewhere, treated, and then it should be discharged. So particularly they are making this sewage treatment plant or the wastewater treatment plants, and they are investing good amount of money. So these are the background about that, and then we'll see what are the wastewater and it's all this. So wastewater management, everyone know about that. I think for the last 4 years you guys must be bored. Kya baat kar rahe hain? Every time it comes and the people are speaking about the generation, treatment, recycle, reuse. So generally these are the principle behind the water management. Whatever the water management, first problem, when we go to the solution, when we get fall sick, we go to the doctor and doctor try to understand what are the problems. So वो लंबी सी list लिख के दे देते हैं, to identify what are the main cause, and you go for the multiple tests, and you will get the number of tests and their parameters and all those things. And then he treat and then he gives the prescriptions. Okay, these are the small 1 goli, 2 goli or 1 injection, and you are fit and fine. So similar, that principle apply for everything in our life. So with respect to the wastewater management, also we should understand our generation, what kind of waste water is generating, what are the composition of it, and the treatment. Based on that, characteristics we can imply the treatment, and then we will discuss about this reuse and recycle. I don't think I should discuss this part, what is sewage, what is the runoff and all those parts, so I will escape it. Problem, you know that generally raw sewage dumped into the water body. So eventually whatever the water sewage or liquid we produce, it's end with the water body. Either it goes to the pond, lake, river, sea. So generally what's happened, water body, particularly the flowing water body or even the large water body, they have a healing capacity. You know, छोटी मोटी चोट हमें भी लग जाती है तो we feel कि 2 दिन में ठीक हो जाएंगे. So they have a healing capacity. That's called the self purification capacity. A small amount of waste, it goes to the water body, it might be diluted, or after some distance of the flowing of the water body, you can find the pollutant quantity is negligible, because the travel time and the condition it's provided, that street and the organic material, whatever the pollutants are there, that gets degraded, and you can get the good water. So they have a self purification capacity. Today, why we are here, why we are talking about that for the last 5 days, that self healing capacity or the self purification capacity is no more. All river is converted into the nala. You go to the coastal line, even in the Mumbai Juhu beach, you can see the black area and all those things. So that's the problem. So the reason behind that, the large scale urbanization, number of people we have, the pressure on the natural resources is so high. The way we are extracting the natural resources, and the healing and all those processes are the slow. So that's today the situations we are discussing here. Eutrophication is the common phenomena we say about that. What is the eutrophication? Basically, there is a water body, there is a lots of nutrients in that. So I mean to say that इतना ज़्यादा खाना हो गया है कि खाने में ही डूब गया हो, you know. So eutrophication is the process where the lots of nutrients that takes out all the capacity, like the oxygen is required for the survival of any kind of, you know, life. So all the oxygen is depleted because of the organic matter, and then it's converted into the eutrophication stage. So those are the major, like that's called the dead stage. After that, that pond or lake will be no further use. So we have to think eutrophication part. Very important. Quantity, how much quantity we have and how much we generate. Generally 80% of water used by the population comes out as a wastewater. So we have to think about that. 100 liters we are using, 80 liters are just wasting. It's no further use. That's just with the number I have given the examples. Niti Aayog has said, generally India, we say that India is a gaon ka desh hai. We have a more rural population as compared to urban. I don't know the recent data. Previous data say that 70% are the rural and 30% are the urbanized area. But you see the utilization of water, 39,604 million liters per day is the rural requirement. However, almost double. We are the only 30%, but the utilization is almost double. And this is not my data. This is the data of the government of India, Niti Aayog. They make the rules, policy for the country. So that's the situation we have. We are consuming more water as compared to the required one. And here another important information. This is also the data from the Niti Aayog. They have given the prediction, and you see most of the waste generated we are disposing without any further treatment. For an example, class 1 city. Class 1 city is called, the population is 10 lakh above, it's considered as a class 1 city. 67% of the wastewater is just going without treatment to our environment. Similarly, for the the class 2, class 3, class 4 city, and they have a gap between that. So this is the very alarming condition. We are in one part we are speaking about that we have a problem, pollution and all those things. Another part, we are not treating it properly, and it's just we are disposing it to the environment. These are some data point, I would say. In 2021, the they doesn't come out with every year data, so 2-3 years or 4 years interval they come out with the data, and they have mentioned here the capacity, the present water treatment capacity is only 27.3%. We are happy we are in the Indore. Indore is the green, clean, neat city, but across the country it's not like that. So these are some concerns we have to think about that. Under the Ganga Action Plan, Yamuna Action Plan, several, I said previously, like the several water treatment plant has been established, and they are trying to treat it. Most of the water treatment plant we were discussing before that are not fully functional because there is just so many limitations on that. What is news? 2022-21. These are the old news, I would say, but these are some major concern we have to think about that. Several pharmaceutical industries in the country, I would say, like Himachal Pradesh, Andhra Pradesh and Telangana, these 3 states having a maximum number of pharmaceutical industries. Himachal Pradesh, if you go to the Baddi, there is so many pharma company. Telangana, Patan Cheru area, they have so many, Hyderabad, that's called Hyderabad, they have so many pharmaceutical companies. So they makes the antibiotics, and what's happened after the manufacturing or discard of those, they are just disposing those wastewater into the water body. And we have to understand that what is antibiotics. Why we take the antibiotics? To kill some kind of biotics, bacteria, those are the pathogenic or harmful to us. What's happened? These water, they are disposing into the water body, and antimicrobial resistant, like some microorganism, they are still survive putting the antibiotics. Like if you remember, previously we used to have 100 mg, 2 mg dawaiyan kind of medicine. Now we are taking a 650, 800 mg capacities medicine. So this is the very alarming condition. We have to think about this, and it was a big discussion across the world, I would say. Generally, wastewater quality, they have some concentration level, like the CODs varies from 1200 to 500 mg per liter. These are some other parameters, you can see it. BOD is 560 to 230 mg per liter. So what are the treatments? Wastewater treatments, we have a sewage treatment plant, we have a wastewater treatment plant, CTP, nowadays we have a combined or effluent treatment plant. So these are the water treatment plants we use, and I think all of you have gone in the last 4 years what are the treatment plants we have. I will discuss here much about some unique treatment plant, that's called the fecal sludge or septage, because these are the very basic one, and based on this we will understand that why it's required. And I at the start of my presentation I said that we have to understand the problem and then we can come out with the solution. This is the very basic one, and we will discuss about that. These are the general characteristics. The pH vary from 1.5 to 12. So you can see the variation of the pH. So we have a
कितनी डिमांड है मतलब वाटर में मैनेज, और COD में हम ये चेक करते हैं कि उस केमिकल डिमांड उसकी कितनी है वाटर में, तो उसके अकॉर्डिंग हम उसमें वो चीज़ ऐड करते हैं.
Very correct, very correct. So BOD and COD is having a very basic difference, I would say. BO is the biological oxygen demand, like the some microorganisms, how much oxygen they require to degrade that kind of substances, whatever the organic substances in the wastewater. However, COD is combination of all. It's a combination of biological and chemical oxygen. Some of the substance, inorganic substances, that can be oxidized, but those are not in the biological nature. So that's captured in the COD. Total oxygen demand, how much oxygen is required to oxidize complete wastewater, whatever the wastewater is there. So these are the difference. So COD will be always higher. Many times I have seen the many experienced people, they write COD 30, BOD 200. Data manipulation. So we need to understand the subject. आपको सब्जेक्ट आता है तो यू कैन प्ले विथ इट, और सामने वाले को आप बता सकते हैं कि वेयर यू आर रॉन्ग, वेयर यू हैव डिड द मैनिपुलेशन. So these are the very important parameters we have to know. COD should be always any time higher than the BOD. And generally what's happened, the sewage water or the municipal wastewater, the COD to BOD ratio doesn't vary much. Because mostly we produce the organic nature in our wastewater. But if you go to the industry, particular industry, there is some chemical industry, the BOD to COD to BOD ratio could be very vast. Might be the COD 5,000, 3,000, 2,000, 1,000, and BOD could be 100, 200. That could be possible because of the chemical nature of the company and the wastewater is produced. And then you have to think about that. Designing parts where the engineers comes in the market. What you have to do, if you understand the background, and then you can design. No, we cannot make a biological treatment plant for this kind of water which is having a BOD to COD ratio is very high. So, like this is the subject, particularly civil engineers, you are going to a design part, you are going to a planning part, you should understand the things, what are the requirement of this wastewater plant designing and all those things. So these are some typical ratio we have mentioned about here. Other parameters also are the equally important, like the NPK. We can say that in our crop and all those things. When we go for the agriculture activity or in our garden, we say that we need some urea, and along with the urea we need some phosphorus and other nutrient as well. So these are the NPK ratio, NP ratio, BOD and nitrogen and phosphorus ratio. This should be a ratio is required to design a plant. And treatment understanding, they have a different kind of method to analyze it, that I have mentioned. pH is another factor we have discussed. Generally the sewage, whatever the sewage or municipal wastewater, pH varies from 6 to 9. However, in the industrial wastewater, the pH could be 1 and could be 14 as well. It depends on the process, what are the process they have. And any kind of treatment activity, pH is the most important factor. pH is the very simple to analyze, and above 7 is alkaline, below 7 is acidic, and alkaline and acidic reaction you understand in our day to day life. कभी कुछ खाना खा लिए हैं, कभी कुछ खा लिए उल्टा, you can start feeling that acidic हो गया है, So it's a similar thing happen with the nature as well. Depends on the pH condition, we can design the treatment and all those parts. So these are some value I have identified and I have given here. Then I think I started parallelly discussed about the industrial, like it has a different scenario. Industry could have a, the flow of water in the different way, like if they have a shift, or if they, some industry they only work in the daytime. So night time there is a no flow, in daytime there is a so much flow of the water. So the treatment plant, it's a machine. I would say it's a machine. It should be designed कि ideal condition में क्या रहेगी, running condition में कैसे चलेगा. So and it's a continuous process. Treatment is the continuous process. It's not like our car, we have a fuel and just we started and gone, and then we have kept it and again next day we have started. It's not like that. It's a continuous process. So that's the pattern we have to understand when we go for the designing of the any wastewater, plant. So these are the different scenario I have mentioned, like there is some in the, some urban area there is only residence, there is some urban area there is a residence plus the small industry you can see around the, if you go to the, even in the Indore, if you go to the some commercial area, there are just so many small industries running in a house and they are producing wastewater. That's going to a drainage as well. So we have to design accordingly and think about that part as well. So here those are problem I have mentioned. So I can summarize wastewater about that. The physical effect depends on the solids or the time variation, temperature as well. So those are the different kind of physical oxidation and residual dissolved oxygen, BOD and COD we have discussed. Every wastewater have a different characteristics that we have to think. Toxicity, maybe some wastewater, all parameters are the good, but there is some toxic substance that kills all the microorganisms and your treatment plant could be fail. So those are the important parts we have to look at as well. Eutrophication we have discussed, and pathogenic effect that everyone know about that. क्या हो गया इसको? यहाँ तो ठीक है. So far we have in the last 20 minutes, it must be boring because might be many things were repetitive to you. But वो आप एक डॉक्टर को दिखाएं, दूसरे डॉक्टर के पास जाएंगे, वो फिर से टेस्ट कराता है सारा, बिकॉज ही इज नॉट हैविंग ए कॉन्फिडेंस कि मेरा पेशेंट जो है वो प्रॉपर टेस्ट लेके आया है या नहीं आया है. सो दैट्स द थिंग्स हैपन हियर एज वेल. So mainly our topic here is to waste water treatment and all those things happen. How we are going to utilize it, how we are going to reduce it, and what are the good practice the company has adopted. So how, like any activity that reduce or eliminates the generation of waste at the source, its best part is any problem at the source, if you solve it, it's a fine. दो लोगों के बीच में झगड़े होते हैं, आप वहीं सॉल्व करा दो तो ठीक है, अदरवाइज पुलिस स्टेशन में जाने के बाद वो कोर्ट तक जाता है और 10 साल तक उसके फैसले होते रहते हैं. So it's a complicated if the matter is goes up to the escalate up to the last stage, right? So think about that, the pollution source reduction, जहाँ पे से वो जनरेट हो रहा वहीं पे हम कैसे कम कर सकें. हाउ वी हैव टू रिड्यूस इट, हाउ वी कैन रिड्यूस इट. चेंज इन ऑपरेटिंग प्रैक्टिस at the operational stage in the industry, particularly with the industry part, if they can modify in their operation and they can reduce some water, that can help to protect the water. Technology advancement. So many technologies are today available to reduce the water consumptions. They have to adopt it. Other inputs like the combination of different inputs, and they can modify their water utilization, they can reduce it. The product. Some products, they are the water intensive. When we go through that, the manufacturing is the very water intensive. We have to modify the product, and then we can reduce some water. So the source reduction is the very important. Recycling. Whatever the wastewater we have generated and produced, it can be recycled in their process. उसको circulate कर दें and again we can recycle it. Like in textile industry, they treat it and again they recycle it. Generally they do it. Inline treatment and close the loop, like the circularity we are saying about that. And close the loop, basically we can say that zero liquid discharge. We'll discuss in the next few slides. So waste volume reduction is the first stage to minimize the industrial waste generation. It can be accomplished by the classification of the waste, conservation of the wastewater, changing production to reduce waste, and reusing both in industrial and municipal, that we have discussed. Might be sometimes I will be repetitive, but these are the requirement. Then the second is the objective is to the strength reduction. So these are the process change, equipment modification, segregation of the waste, equalization of the waste, and byproduct recovery. Process change and equipment modification, I have given the example. Segregation of the waste. This is the very important. If you have a industry, they have a very complex process, different types of wastewater in the different steps they generate it. Sometimes very small amount of the wastewater they generate, that's going to spoil the entire waste flow. So they should separate it and give their a special treatment to the small amount of the small volume of the waste, and other wastes can go to the general treatment, so they can reduce the cost. So these are some small example I'll show you in the next few slides. Equalization of the waste. Another way, there is some complicated waste and there is some normal, equalize it, neutralize it. There is some alkaline waste, there is some acidic waste. Equalize it, and it could be a neutral pH 7, and then you can have a better treatment of that wastewater. By product recovery, you can recover so many products from the important product from the wastewater treatment, because many industry in their wastewater, they produce the very precious thing. It goes to their waste. That can be recovered. I'll give you the one small example in our day-to-day life. Mostly, no, I think the 50-50 ratios. Anyway, the girls and the boys. Generally, if you go to generally girls mostly they go to the क्या बोलते हैं सोने की दुकान to clean your ornaments and all those things. And those people, they used to clean it and give it to the very shining your gehna and all those things, and we are happily comes. But if you notice that the extract who has cleaned, they have kept it very nicely. When you left every day, and they recover the metals from there. What an interesting thing. 5 रुपये 50 रुपये में वो शायद क्लीन करते होंगे या 100 रुपये में, बट माइट बी 200 रुपीज़ का तो सोना उन्होंने निकाल लिया उसमें से. So and then they have a different process to recover it. So similar way we can think about the industry, big large scale as well, like they can extract so many things. There is one plant in Pune. So they have a bearing manufacturing, and their wastewater is acidic. What they do, they neutralize to alkaline, and all the precious metal they settle it down and they recover it. Very simple. What are the motivation? I don't know, you guys are very early stage. What the world is doing today, particularly in the industry sector. All industry, all the development and all those things. Everyone is speaking about the circularity, circular ecosystem, close the loop, stop the linear and close the loop. What is this linear and the circular? And I'll bring it to a very simple way. Some product we manufacture, we use and throw it, linear. You know, some product we produce, we use, we treat nicely, and again it's reused. It's called the circular. And today across the world, everyone, all the industry, I think if you read the news articles of the industry, what they are doing, every industry they are speaking about the circularity, sustainability, ESG. Why? Every industry they have set the target goal. You know, this is the new era. It's not like the 10-15 years back. This is the new era. In the last 2-3 years, world is changing very quickly. Every country they have a target to achieve a net zero emission. India has a target in 2070 we will have a net zero country. It means whatever the carbon we are producing, the same amount of carbon we are reducing. So it's balance. We are not contributing any single carbon to the environment. So that's the net zero. We have a target. Every country have a target. You know, the country has a target. The targets country, कोई country अलग से तो है नहीं. It's a targets comes to the us as well. Individual, institutions, and organizations, industry, everyone has to work on that and should be the neutral, carbon neutral country or the, you know, the system. Even your academy, IPS, they must have some plan to be a carbon neutral and utilize the 100% of the wastewater. So to achieve this, different other factors like we have a resources and all those things, and that I think all those part I have discussed, but these are the motivation we have to come to the circularity. So once the wastewater has treated, we are reducing, recycling, it should have a standards. CPCB, Central Pollution Control Board, is the agency who made the standards to discharge the wastewater or the treated water, whatever there is some regulatory authority for everything. Na? Similarly, for the wastewater discharge, disposal, we have authority, Central Pollution Control Board, they make the rules, not rules, sorry, standards. I am the committee member of the one of the standards who decide the wastewater, disposal and others. So big discussion happen. There is no technology, there is requirement to have to bring the pH to 7. There is no technology available to bring the pH up to a 7. And the big discussion happens, and all the people, there is 20-30 people, all the professors, academician, industry, they discuss and they come out with the solution. So anyway, these are the some standards has given for the inland disposal, for the public, for the on land, for the marine disposal. These should be the standards has to follow before the disposing to your treated wastewater. So several technology are available for the treatment. So anyone has discussed about the zero liquid discharge in the last 4 days? Good. So you know the what is the zero liquid discharge and you know and why it's required. Generally, whatever the it's a kind of, you know, as we discussed, it's the closed loop system. So whatever the water we consume, we doesn't drop any single water to outside, it circulates in our system. There it's required a very expensive machine and the power consumptions, because it's having ultrafiltration, reverse osmosis, evaporation, crystallization, and the fractional electrode ionization. So these all system is very expensive because it's required lots of energy to run this. So we have to decide our treatment plant is required the ZLD facility or not, because it's the cost incurred to establish this technology is very important. So being a civil engineer or designer, tomorrow you are going to join some organization and somebody blindly comes and they can say, you know, ZLD, there is so many industries, they are just selling it. They will come, ZLD लगा लो, सारा problem solve हो जाएगा. But think about the operation cost. Is that feasible for our industry? I have some small industry and somebody recommending के ZLD लगा लो is not possible. It's not required as well. Go to the common effluent treatment plant, send your water to the CETP. So that we have to decide. Some of the wastewater it's very difficult to treat. So the ZLD is effective. You have a very small area, you don't have much area to handle your water, and those wastewater whatever you are generating is very complex. It cannot get treated easily. So you establish this is the technology, it's very helpful. Mainly the salinity and other factors who are considered for the ZLD. This is the flow of the ZLD, like the fresh water utilized and the wastewater produced. Then you have a ZLD where all the wastewater it's recovered and you can use it again. And then the solids present in the wastewater, because it's a dry technology, so it's a solid, you can recover it or you can dispose it, depends on what kind of solid you have recovered from the ZLD. Many companies, they are recovering, but they are thinking about to recover. No one is recovering. All is going to the hazardous waste landfill site. But yeah, that's an option, and with the time we can come out with a major good resource recovery. The same things how it's achieved. The benefits we discuss, it's lower the volume and it's a cost associated with the waste management. Recycling. So many regulatory authorities, particularly State Pollution Control Board, they recommend to establish the ZLD depends on your wastewater characteristics, location, where is your plant is available, and then they recommend to adopt the ZLD facility. So now we are in the another section where we can recycle or reuse our wastewater. So I found this is very interesting, I would say. A tree, the wastewater, you have a wastewater, treated wastewater, it's a kind of resources, and where we can use it. Building, air condition में use कर सकते हैं, cooling, snow melting, fire extinguishing, flushing, toilet flushing, sprinklers, recreation, landscape, cleaning, industry, agriculture. So whatever the wastewater we generates, we can 100% we can utilize. It's a very resourceful material. Only problem is that we don't have a mindset, we don't want to take the one extra steps. Like the many industries, they have a treatment plant and they have a little cost to send the water for the some recreational things. They will, no, we will discharge it. So that's the problem. Otherwise, you can utilize the 100% of the water. In the urban area where we can reuse the treated wastewater, in the urban area, particularly in our city, like we most of the big city, they have a golf course. They can use those treated wastewater. Residential film and the landscaping, field and the landscaping, there we can use. School yards, like our university here, you can go see there is a lots of landscape. You can dispose your wastewater, treated wastewater, not the wastewater. Office park, highway made in, like, you know, nowadays we have a very good highways. It's really, I'm surprising, this country is moving like anything. It's better than the US, and sometimes I feel like the highways quality and the way they have made it. So in between the, you know, the highway made in, they're just so broad, they are planting a big tree, they can use this wastewater. Athletic fields, parks. Fountains, nowadays the rich corporation, they are making the fountains in the industry to attract the people, feel good factor. So there we can use it. Fire protection, that we have discussed. So, you know, the urban, whatever the municipal wastewater or the urban wastewater we are generating, we can use here all these parts. I mean, in Indore, what to say about this, you know, Indore is the first city who is the water plus city. 2021 Government of India has recognized out of the 84 city participated in the competition. So that's the first, you know, we have a long journey. The first step, Indore has recognized, maybe the tomorrow another city will recognize. Once you recognize, your responsibility to be like that, you know. Once you recognize, and tomorrow you cannot throw the water here, untreated water here and there, otherwise people will ask the question, how you get the recognition? So they have to behave like that. So Indore is the first. So how they have recognized that, all of you from the Indore must have gone know, and you feel proud. Even I feel proud, because many places I give the Indore model as an example with respect to the waste management, solid waste management, and water as well. Industrial reuse. Industrial wastewater can be reused in a cooling tower. That's required a good amount of water. We should use in that. Boiler feed water, cleaning in the industrial site, process. You know, electronics industry, prepared food, manufacturing process, pulp and paper industry, textile industry. They can use those wastewater. They are using as well. You know, the treated wastewater for the, you know, for the saving the, not taking a new water or the fresh water. In the power generation also they are using the flushing toilet and all, recreation as well. I think I am boring. So I'll give some example of the industry. Today, almost 100% of the industry, they have a target to be water neutral industry. They have a target. Some industry they have a target 2025, some industry have a target to 2030, some industry have a target to 2040, 50, whatever, that depends on the industry process. So recently I visited this industry for the assessment, and I found they are doing the good part. So they have been the water positive, because whatever the water they extract, more than that they are producing, and we will get surprised how it can be possible. Like whatever the water one industry, there is a little trick, whitewash we can say that, but how it can be possible if I am using 100 KLD water and 110 KLD I am positive, how it possible? It's impossible. But there is some process. They are doing so many good water recharge, rainwater harvesting and other conservation measures, and they are counting as well. So this is the industry. It's Ashok Leyland, I think. Yes, it's in this industry is in Haridwar in Uttarakhand. So here they have given the water balance as well, how they are reducing, and they have converted to a water negative to a water positive through the the spring recharge, rainwater harvesting, in-house pond as well. So they have conserved the water. In addition to that, they have a zero liquid discharge facility. So whatever the waste water they generate, they are recovering, and in addition to that, they are recharging the water, and they are the water positive. Where they are using, what are the method they are using, like the 3M methodology they follow to conserve the water. And one very important things I would say. So anyone understand the KPI, key performance index? So if you will join any organization, generally we join as a junior position, right? Must be a just engineer or just manager or assistant manager kind of position we will enter. But there is a lots of hierarchies there. The top management, the company ka honor. Many companies, the big company, there is no honor. There is a CEOs, MD, CEOs kind of people. They are the just employer of the company. So they are the main decision makers, and if they are thinking about the water treatment, water utilization, water reuse, then only it can be adopted by the everyone. It should be start from here. Whatever the decision, आप हम नहीं ले सकते हैं, प्रिंसिपल साहब लेंगे, So the water conservation plan is the KPI is the the key performance indices, means whatever the person in the company, you have some KPI, you have to fulfill that KPI in a year. What you have worked, like for an example, if I am the assistant professor, my one of the KPI is to work something about the water conservation, take a decision, invest some money in a water conservation, in addition to my other work. So KPI is in the industry, every people have their KPI. Even my one of my KPI to do the awareness session. I am here and delivering this session about the wastewater treatment. So that's my KPI. So any industry, if their top management is taking a decision, then only the I would say actual work will happen. So you people have not exposed to the industry. It's your first stage. It's very good you are listening from me, and you will be remember once you into a organization where they will say about the KPI. This is your 2-3 KPI. There is one more company I did the assessment. It's ABB India Limited. They have also turned to a water positive. I was the auditor of this company, and they have a water positive index of 1.24, means 24% water, whatever the water they have conserved, 24% water they have additional they have conserved, whatever they have utilized. Means they have utilized the 100 KLD, now they are positive with the 124 KLD. So these are the different steps they have followed it, including the the water rainwater harvesting as well. And water conservation or water utilization, small step. वो बोलते हैं ना, बूंद बूंद से समुद्र बनता है, drop drop से we make the islands, right? So basically what's happened, if you see a simple example in at our home, if you see one drop of water is from our tap is leaking, right? You put the bucket and overnight or over day it might be half filled or full filled. Industry में ये allow नहीं है. They cannot waste a single drop of water. So wherever possible they will conserve it, they will recycle it and reuse it. So that's how they are coming out with. I know one of the industry, yes, I have not, I think not included. One industry, they didn't do anything extra, and they say low hanging fruits, means they just manage their water supply system properly, captured all the waters, and they saved almost 30% of wastage of water. So just fixing the joints, the leakage and all those small things, and that can be happen easily. Just people are neglecting, and those are those water we just leak it or we just dispose it. It's not good part. So that's also very important. Like in our municipal corporation, if you see the water balance, every municipality 50 to 60% water is just going waste. Like कहीं leak हो रहा है, कहीं कुछ हो रहा है, कहीं proper treatment नहीं हो रहा है, and then it's going just wasting our water. This is the another plant, the Hero Motocop. They are the water positive 21.114, 200%. So they did the really good part. I did the assessment last year. They got the best corporate sustainability award from the CII. I was the assessor for them. So they have all these facilities, zero liquid discharge and all those, and they are utilizing. So I would say, today all industry, they have a target. What we can do, being a entry level professional, we should keep our mind open and be innovative. Look around you, look around the institutions, and think something innovative to come out with a new idea and come. The traditional wastewater treatment, you can see there is a lots of wastage. We cannot use the much water. So think some innovative. You are the entry level. The way I think and the way you think will be completely different. I will think only one part. This is my concept and this is the way of the treatment. I will not go much, but you have a lots of opportunity to think different way and come out with a good idea. This is another industry. They have saved around, they saved around, I think, 5,611 MLD meter cube water to around 3,900. So almost around 2,000 meter cube water they have saved because of the, the process they have adopted in the modification, the RO plant and other system. And now they have a zero liquid. Previously they used to have a disposed of treated wastewater into a drain. Then another example I will say about the Aditya Birla Group. Oh, sorry. So Aditya Birla Group, they are applying a 4R principle. What are the 4R principle? First, to reduce, how they are reduced, where they have to reduce, how much they have to reduce. So it's a very big company. I think India top 5 companies, big size company they have. So that policy applies to all small company they have and the bigger as well. So to reduce, they are reusing, they are recycling, and they are regenerating as well. And by this method, they have reduced the 47% of a specific water consumption in their textile industry. Textile industry is the very water consuming industry. They consume very good amount of water. And always we say that textile industry, dealing with the textile industry and their wastewater is very problematic. They are the notorious in a water pollution industry because they use the dyes and all those things. They are not easily treated. So they have in the process, then the design, the way they process it, in the process they have reduced the water consumption. तो जब हम कम लेंगे तो कम ही generate होगा. It's very simple. So they have reduced 47%. It means the previously they were using the 100 KLD, now they are using the 53 KLD of water. And then they have other method to reduce as well, like the the ZLD they have and the others. Environmental use of water is, we know very well, everywhere. Like we can have a big pond, recreational pond. We can recharge our groundwater. The factory they can use it. So restoring habitats. Maybe if we can go to some lake, and those lakes are dying because of the lack of water, we can, if we have our good quality of treated water, we can use there and we can regenerate the habitat in those I would say the wetlands or the ponds or because the ponds, lake, they have their unique ecosystem. It's required the protection as well. Supplement stream and the river flow. In the summer, particularly in the summer day, many river they don't have a flow, they have a zero flow. Go to Delhi, Yamuna, there is no flow. Water ही नहीं है. So treated water can be, treated water is coming there, but those are not treated. So it's converted into a nala. So those are the examples I would say कि treated water can be used in those parts. Groundwater recharge. Another very important is the salt water intrusion barrier. Particularly in the coastal area, what's happened? The groundwater or the water body, if we have fresh water body we have extracted. So what's happened? The coastal water or the marine water, the water exclude and it comes in and their area is getting increased. So if use this treated water in those places, it can stop the water intrusion, salt water intrusion. Best part, agriculture reuse. Treated wastewater is very favorable. Everywhere across the world, people use the treated wastewater in their agriculture practices. Many crops, we can use it. Here I have listed it where we can use. So irrigation has the advantage of closing the loop, I said previously. Combination of water disposal and the water supply. Irrigation reuse is also more advantageous because the possibilities of decreasing the level of purification, hence the saving the treatment cost thanks to the role of soil, crop and biological treatment facility. Very interesting chemistry happens. Soil, crop and wastewater. It's very interesting chemistry is there. So I will quickly go with that, and please let me know the time limit for me once. So I will just, these are the driving factors when we think about the the water management, water reuse, these are some driving factors we have to keep in the mind. wastewater management, policy regulations, and the technology we have or not, finance, because the finance is another very important part. So if you will allow me 5 to 10 minutes, I can quickly go with one case study. Okay. So this is a very my favorite topic. High rate transmission system might be yesterday or day before yesterday. Some expert has spoke about this, the nature-based technology. So why I found it very interesting, because this is having a minimal cost and more benefit. So its impact, we know that it's impact on the reduce the load on MIDC infrastructure. Why I have mentioned the MIDC? Most of this technology has adopted in the Maharashtra. So Maharashtra is the Maharashtra Industrial Development Corporation, something like that. So they produce the water, so load will be reduced on that. So this is the alternate source of water for the green belt development. Eliminate the hazardous cost and the greenhouse emission, solving the fossil fuel emission, eliminating the requirement of diesel. So these are some benefits it has been mentioned. Green belt, every industry, if it's required, every industrial activity, even our housing societies, new housing society, it's mandatory to have some green belt. The industry generally it's mandatory to have a 33% of the green belt, because in our country, India is having a target to have a 33% of the green belt. So that applies to everywhere. Whatever the construction, whatever the activity we are doing, the government has mandated to have a 33% of the green belt. And we know all the benefits of the green belt. The guidelines is available. So our rules also recommend it to have a green belt and utilization of wastewater in a sustainable way, particularly a recycle and reuse part. And every industry has to, or every activity has to achieve the ZLD, zero liquid discharge kind of thing. So it's not only we can have a zero liquid discharge based on the the high quality RO and other system. We can adopt the other method as well for the achieving the zero liquid discharge. NGT also has order, and then the NEERI has designed this, and I think therefore study they have explained it. So high rate transpiration system and the reverse osmosis or multiple effective evaporator. To achieve the ZLD, we have two methods. One is we can have some machinery where we can do the reverse osmosis process, and then we can have evaporate all the remaining water and get the salt separate and condense the water and get the water. That's very expensive. However, the high rate transpiration system is the combination of soil, plant and water, wastewater. Utilizing this wastewater, and you can have a zero liquid discharge as well. I will explain a little bit about in the next slide. These are the technology available and the solutions, and how the ZLD will HRTS high rate transmission system is more effective. That's explanation I have given. CPCB also has recommended the high rate transmission system for a effluent treatment plant, particularly those are the problematic industry. Their treatment, their wastewater are I would say very complex to treat. One of the industry is the tannery industry. So what are the tannery industry, what are the wastewater. If maybe in future you guys will get a chance to visit a tannery industry, next time you will not say I want to go again to a tannery industry. It's very smelly. They are doing the tanning of the leather and all those things. It's very smelly, very ugly industry, I would say. So for them, treatment is very complex because they use the chrome tanning. So chrome tanning process, I don't know how much you will understand that. So they use the chromium kind of metal. Chromium is the toxic metal, and they do the tanning, means they have a leather, and the leather they clean it with some chemicals. Those chemicals, after the cleaning, it's coming to a wastewater, and it's very difficult to treat. So high rate transpiration system and other conventional method, here the the comparative comparison has been given. It's a more cost effective than the any other method. The current method we have already discussed, the physical method for the treatment, like the dilution, equalization, separation, screening and sedimentation. Chemical, there is just other chemical treatments, biological, and the tertiary treatment is the RO and the multiple evaporation system. So that's we have already discussed. So basically what's happened, CSI-ITC is the pioneer environmental organization in the country. It's a National Environmental Engineering Research Institute. It's in the Nagpur, Mumbai, Delhi, Hyderabad. They have a different center. So this is the pioneer in the environment sector. They work particularly to every aspect of the environment. So they have designed this HRTS system. It's called the land treatment system, where it consists of the ridges planted with the high transpiration rate potential species, and the furrow laid with the filter bed media. So they have a special kind of media, filter bed media, and in the ridges they plant the tree, and in the furrow they put the media, and then they dispose the complex, particularly the wastewater having high salinity. So they place those wastewater in that region. So the plant, they have a high rate capacity to absorb the water, because they have a evapotranspiration rate is very high. For an example, the bamboo. 1 year it can be very happily grow. It takes 1 year, 2 years, it can grow very quickly. So if you plant the bamboo around that, it takes all the water, your water gets utilized, and you can get the bamboo as a plant and utilize in your industry wherever you want. So just disposing, it's another part. So this is the ready-made solution, the plant, filter bed, media, soil, microbes. All the 6R principle works here. It's renovate, it's reuse, kind of regenerate, groundwater recharge, restoration of the land. So this technology has been applied in I think more than 50 industry in the country. All are the complex wastewater producing industry. For an example, in Madhya Pradesh, there is one pulp and paper industry in Shahdol district. Amlai Orient paper mill they have. So they are the pulp and paper industry, and they produce the wastewater which is having a high content of lignin, colored wastewater, dark brown color, and those wastewater treatment is very expensive, because lignin is the one of the substance that could not get easily degraded. So that's why I said BOD to COD ratio we have to understand. So then we have to dig it down to what are then another specific compound who is responsible to the wastewater is not able to get treat. So lignin, because of the tree, paper made with the tree and plant, so all the good part like the white paper we extract it after the pulping process, and then the lignin and other substances released into the wastewater. So treatment of those wastewater is very difficult. So they have applied this wastewater, this technology in 2019-95. For the last 35 years, that plant is running. 30 years, the plant is running very nicely. So these are some benefits. Yeah, here they have listed where they have planted. Before establishing this technology, they have tested in laboratory, because you guys are the very new. You are the students. So once you will go to to industry, you should understand that it's not blankly we can come out with that. Okay, these are the wastewater, these are the technology, we are going to use it. No, it should go first at the laboratory scale study. In a small bench scale, they do the study, they put all the ingredients in their study, and then they identified, okay, these are the treatment process, effective treatment process, we can apply it on the field. So they did a bench scale, then the lab scale, and then at the plant scale. These are the some components which has been given, like the wastewater disposal, the plant at the regeage and the evaporation net. So just I have finished. Oh my God. The advantages, you know, that it's a green technology, economic. I just wanted to show you this slide. Yes, this is the slide. So these are the some plant species they have identified, and these plant species, based on the research that it has been published by some researchers in the different journals. Peer reviewed journals, and based on that they have identified this plant can be used in the treatment process. So might be I took little 10 minutes extra time, but it's really nice to interacting, and this is my first time. Generally I used to speak in the front of industry people, those are the subject expert, so many things I don't have to say it, like, you know, the basic information that we have to discuss about the much higher discussion point, like how reusing and recycling and the cost part as well. But it was a very nice to interacting with the students, and you guys are not from the environment background, you're civil engineer, and you know the difference between the BOD to COD. Otherwise even the environment engineers, they doesn't know much about this. So thank you all. This was my last slide. So I hope you have any questions. So I'll be. So I can explain little. Yes.
So in the process of killing the pathogenic microbes, won't the required ones get killed also?
Sorry.
So in the process of killing the pathogenic microbes, the required ones which are necessary, won't they get killed also?
I couldn't get you. Who will get killed?
So जो pathogenic है, जो disease causing microbes है, तो water से मतलब treat करना ज़्यादा ज़रूरी है. जब हम उनको treat करेंगे तो जो required है, जो हमको चाहिए आगे microbes, वो effect नहीं होंगे उस.
Definitely होंगे.
तो सर फिर कोई ऐसा alternative जिससे हम बिना effect किए pathogenic microbes को भी हटा सकें.
That's why the wastewater treatment plant is there. So what's happened? It's a very basic principle. Our sewage, it contains the pathogenic microorganisms and all those kind of microorganisms, right? So in the environment, all the microorganisms are not pathogenic. I would say out of 100 types of microorganisms, only 5 to 10 types of microorganisms are the pathogenic. Rest microorganisms are good for humans. They are the good requirement. So what's happened? In the treatment process, the primary treatment, secondary treatment, in the last 3-4 days we have seen, and the last is the advanced treatment where we kill all the microorganisms. But once it goes to the environment and exposed with the environment, all the microorganisms are in the environment. They will come and they will grow, those are the good part. But the pathogenic has to be killed. What's happened? The news is that some of the pathogenic microorganisms, they are getting resistance with the antibiotics. and they are available in the environment. For an example, the best way, what I can tell you, mosquito. Previously we used to have some kachua agarbatti, something like that in 90s or 80s. Now those are not effective. Now we need the more powerful some mosquito repellents, because they have got the resistance of the whatever the small quantity of the mosquito repellents we were using. Similar with the pathogenic microorganisms is happening, and that's the concern. That's the concern, because once some of the pathogenic microorganisms, they are resistant to that antibiotic, once we will fall sick, when we will get sick, the antibiotics will not be effective to us. And then that's called the superbug. I don't know if you guys have read about or not. Superbug. Might be you guys go through the game and all those partner. There is one game on the superbug. So it that microorganisms cannot get killed, and it's making us it's spreading a disease to everyone. So that's a kind of situations is happening now. So that's killing the microorganisms is required, but after next, like the 90% of the microorganisms are the good, and in our environment they will come out and they will grow in that system. So that's killing is important. Might be we are during the killing process we are killing the all types of microorganisms. That's why interesting. Now we have a RO in our home. RO, it kills everything. It extracts everything. Only we are getting water. Even we are not getting the nutrient in the waters. And now there's the doctors or the regulatory body, they say ki, don't use the RO water because it's not having a minerals. Similarly, it kills all the microorganisms. Some of the microorganisms are good for our gut. There is the good microorganisms, like in our curd we get the good microorganisms. So yes, any question? Water reuse and utilization.
सर एक क्वेश्चन है कि जो वाटर हम लोग बार बार रिसाइकल कर रहे हैं, क्या उसकी क्वालिटी जो रहेगी, जो मिनरल्स उसमें रहेंगे, उसमें कुछ चेंज आएगा? जैसे कि आपने बहुत सारे प्लांट्स का बताया, लेट सपोज वो जो प्लांट है वो वाटर निकाल रहे हैं या कहीं से भी ले रहे हैं, फिर देन उसे यूज़ करके फिर उसको रिसाइकल कर रहे हैं, फिर सर जब वो ये प्रोसेस 5 या 10 बार चलेगी, देन उसके मिनरल्स में कुछ चेंज आएगा?
Good question. Civil engineer can ask this question. So what's happened? I will give you the best example of the civil engineer aspect as well. During the, generally what the people think about the civil engineers. Civil engineers will come and make the buildings, but civil engineers do the many things. So in the construction of the any buildings or any structure, we require the several types of material: bricks, concrete, metal, steel, and what else? Water. Then we will have a construction. So water, can we use any kind of water for the construction?
No.
It's required a particular types. It's standards, it's mineral contents, it's a salt content, it's pH, everything should be specific. There is a range they have given. So the similar for any kind of industry. For an example, there is a textile industry. They required a very specific type of water. Some pharmaceutical industry, they required a distilled water in the many process. Distilled water means pure water, nothing, no minerals are there. So every industry, every process, they have a unique requirement, but your wastewater, it's a heterogeneous. It's having a different kind of waste. So if you recycle or reusing the water, the water should be come to that required standards. If it's not matching that standards, we cannot use the water. So we cannot use the water, then we have to use in the another process. For an example, a pharma industry, they required a very specific industry. I will say the very important, interesting example. Recently I have come to know. There is one company who manufacture चिप्स का पैकेट, यू नो, चिप्स का पैकेट और चिप्स के ऊपर जो पैकिंग होता है उसके ऊपर वो, एंड दे आर नॉट यूजिंग द रिसाइकल वाटर. आई आस्क व्हाई द रिसाइकल वाटर इज मैचिंग योर स्टैंडर्ड, व्हाई यू आर नॉट यूजिंग, यू हैव अ ZLD एंड यू शुड यूज इट. दे सेड इट्स पीपल साइकोलॉजी, मेनी पीपल्स दिस फूड पैकेज यूज इन द पूजा, दे विल से कि रिसाइकल वाटर है, गंदा पानी से बना हुआ है. You know, so then what they do with that water? They are using that water in their landscaping, their flushing, their cleaning and other part. But for the manufacturing of that package and paint, particularly they manufacture the paint, like the whatever the food packet we are getting, and they have nicely paint with the different design and different forms, na, different colors. So they are making the paint. So they said that some people they use the paint in their puja ghar, so they will feel कि ये गंदे पानी से बना है paint. So if they will not use in the process, they will use in the some other process. आपके पास प्रोडक्ट है तो उसका बहुत डिमांड है मार्केट में. So it's the characteristics gets changed once it gets treated. It's definitely will have a different characteristics, but it has a different use as well.
Any other questions? Okay.
So thank you. It was a nice interaction, I would say. Thank you, everyone.
Thank you so much, sir. It was an indeed wonderful session. Now we are moving ahead with our next session. We have Mr. Mayur Shirish Jain sir with us. He is an assistant professor CED IIT Indore. He has his research interest in solid waste management, biological transformation of organic waste, soil revitalization via nutrient recycling, sustainability assessment of smart cities, sustainable construction materials, green building assessment. He has been recipient of Young Achiever Award 2020 and recipient of the MHRD Fellowship for PhD Best Paper Award ICWE 2021, MANIT Bhopal, and also awarded Best Poster Presentation Recycled 2016 by IIT Guwahati. He has 17 paper publications in journals, 5 book chapters, 36 conference, international, national publications, 19 UG thesis guided and 1 PhD thesis guided. He has done his PhD in Environmental Engineering IIT Guwahati, MTech SVNIT Surat, Environmental Engineering, BE in Civil Engineering. He is reviewer, PEER reviewer in various 17 international national journals and 1 book, invited as a resource person in webinar conference 16. On behalf of all the students and teachers, I thank sir for providing his gracious presence to join us today to enhance our joy.
It's not required. हाँ वही
बैक DST लिखा होगा, हाँ वो so we have remote or something to change from here. Okay.
The slides will change.
Okay, fine. This is mic only, no?
Yes.
It's fine. ठीक है. Okay, so good afternoon to all of you. I think that was a wonderful introduction by one of your students. I think there were a lot of sessions were conducted by different people from the industry, maybe from the academicians. So I have been asked to to discuss as less as possible. So I'll be discussing as less as possible in terms of what we are doing at IIT Indore, right? So I'll be talking about latest. Okay, there is any issue with the storage? I think there is an issue with the storage. प्रिंटर से डायरेक्ट नहीं चालू होगा क्या? So anyway, we'll be talking about latest insights on the wastewater treatment. I'll be starting with some of the basic understanding. I think most of you have already gone through that. A lot of sessions already done, and we'll be focusing what the different activities we are doing in terms of the natural systems, how the constructed wetlands can be used in terms of reducing the wastewater pollutants. Yeah, I think. Yeah. Okay. Yeah. So this is a race towards SDG 6. I hope you are already aware about SDGs. There are different around 17 sustainable development goals given by the United Nations, and the most of the target given by them is 2030. But again, India is far behind in terms of achieving all those SDGs. But in terms of wastewater technology, we can say that we will be trying to focus on achieving SDG 6, that is clean water and sanitation, right? So currently I am also leading a group at IIT Indore, that is Stuti, the Sustainable Waste Utilization to Enhance Economy. So this is one of the research group that we have at IIT Indore. It takes time? My God. Don't we have any remote or something? If we can. Yeah, I think it is there, but I think it is taking time. I mean, find if there is any alternative. Anyway, so moving about the India's water demand, we already know that there are different sources for the water, fresh water, and you can see average annual precipitation is around 4,000 billion meter cube, but out of which the river system is estimated to be around 1869 billion meter cube. And again, the concentration of rains because of the runoff and all those things, only 690 billion meter cube of water is available for the different activities, whether it has been the domestic activities or industrial activities or agriculture activities. I hope you are aware that most of the fresh water is consumed only for the agriculture activities. Around 80% of the water, fresh water, is consumed in the agriculture activities. Then it goes for the domestic and industry, and then it goes for the domestic, around 5%. But when we see the other part of the wastewater, we can say that most amount of the water coming from the domestic, right? Although we are using more amount in agriculture, but the most wastewater is coming from the domestic activities. There are a lot of domestic activities. I hope you might have studied in your water classes, right? that is around 135 LPCD, that is liter per capita per day is the requirement of the fresh water. So we can say even in the Gita it has mentioned about the Ganges. Ganges are facing lot of problem, the river Ganges are facing lot of problem in terms of the wastewater which are being disposed by various activities, and you can say that the Ganges is considered to be the 5th most polluted river in the world, right? So we have reached to the world, although some of the IITs like IIT Kanpur, IIT Guwahati, IIT Varanasi, they have working on the Ganga action plan in the rejuvenation of the Ganga river, but unfortunately the work is still pending in terms of the rejuvenation of that particular river. So there are lot of challenges in terms of this river Ganges, right? Can you give me that? If I'll do that, that will be great. Okay, okay, yeah, that will be fine.
HDMI केबल है उधर सर, इसको ये लगाना चार्ज उसमें 10 मिनट टीवी के नीचे न्यू वॉल्यूम डी में कर रहा हूँ।
हाँ, इसमें
बना लेता हूँ। सही है, चार्जिंग
अच्छा कॉपी कर रहा हूँ।
शायद से सर पीपीटी बड़ी है, इसी वजह से वो
maybe and it has lot of images, no? So ठीक है,
इसे सर फिर हम यहीं से
बस that will be great. हाँ हाँ,
स्लाइड शो इसको यहीं से खोल लो।
ठीक है,
चला
yeah, ठीक है, yeah, so thanks a lot. Okay, so moving further, we'll be talking about overview of traditional wastewater treatment technologies, how traditional technologies are working in India. Then introduce and explain emerging wastewater. So there are a lot of advanced technologies are coming up, like sequential batch reactor. Then we have a moving bed bioreactor. So there are different technologies. Even some of the technologies are already installed in different IITs so that they can understand its efficiency. We'll also focus on the successful implementation of those in terms of the case study. Maybe 1 or 2 case studies we'll go through. Highlight the advantages. This is very important because if we do not understand what are the pros and cons of a particular technology, we cannot shift to another technology. We'll also focus on future directions and challenges that we'll be facing in coming time, trends and potential developments, and try to understand the cost effectiveness, scalability and environmental impact. So if we talk about definition, I think you are already aware what is wastewater. It's nothing but the water which is coming from the different activities, maybe from the domestic activities, maybe from the industrial activities, maybe from the agriculture activities. I hope you are already aware about the different parameters that need to be checked while while going for the wastewater analysis. Anyone can tell me what are the different parameters that we need to check in terms of the wastewater? I hope third year students may if there are any third year students, they can give answer. COD, okay. COD is generally comes when we talk about the industrial wastewater, right? When it comes for the domestic wastewater, generally BOD we talk, right? Okay. What about TSS? Yes. Okay. What about any other parameters? pH, okay. TDS, however, won't be that much important in terms of wastewater. Anything else? Okay, so just to tell you that many people in India or many municipal corporations in India, they do not generally focus on the alkalinity and hardness. So these parameters also affect your wastewater treatment. So that's one of the research that maybe the municipal corporations are not focusing. But yes, if there is a change, slight change in alkalinity or hardness level, that may affect your complete entire treatment plant, right? So that is something which we have to understand in terms of how research is helpful. Okay, anyways, coming to types of wastewater, we are already aware there are a lot of types of wastewater, like some water coming from the domestical resources, some water coming from the urban runoff. It also contains lot of suspended solids. Industrial wastewater contain lot of pollutants. Maybe it can be the pharmaceutical pollutants, it can be the microplastics. Have you heard about the microplastics? Now entire world is focusing on the microplastics. So कहाँ से आ रहा है ये microplastics? Pardon? Okay, single use plastics. Besides, please yes, tell. Okay, ठीक है, बिस्लरी water. Okay, so whatever the plastics material we are using, because of that some amount of plastics are leaching and ultimately it is coming in your wastewater. But are you aware that whatever the face wash you are using, they are also having the parabens, which also contributes to the microplastics, right? So most of the what we can say, the microplastics are also coming from the cosmetics. So that's again a major issue in front of world, that we are not able to treat the microplastics in a appropriate way. There is one study recently published by Professor Subrata Hayat, IIT Patna. He not IIT Patna, yeah, IIT Patna. So he focused on the microplastics in the rainwater. So that's a very very challenging thing, because if we generally say that rainwater is the purest form of the water that can be drink, right? But let's say if the microplastics are coming in the rainwater, then that is very challenging for the entire world in terms of managing such kind of pollutants, right? Okay, so coming to conventional wastewater treatment process, we are already aware that there are different types of processes like physical, chemical, biological. Biological, chemical, physical, all those processes are included in a same treatment plant, so that the whatever the water will be getting, it will be more efficient in terms of either recycling or maybe the reuse, right? So we have a preliminary treatment. We can say preliminary treatment is nothing but the screens or grit chamber, or maybe mostly screens or primary sedimentation. Then primary treatment, we generally focus on the primary sedimentation and grit chamber. Then we have a secondary treatment like aeration tanks, right? And again the secondary clarifier. We have a tertiary treatments that generally includes removal of nutrients. That's again one of the problem that we are facing, because lot of fertilizers we are disposing into the natural surfaces, and due to fertilizers there will be lot of nutrients like nitrogen, phosphorus and potassium, and no conventional process can remove those nitrogen those nutrients effectively, right? And at the end, if you want to move for, let's say if you want to go for maybe recycling or maybe reuse, then you also focus you have to focus for the disinfection, that is process of killing or removing disease causing microorganisms, right? So primary treatment, these are some of the design parameters. I will be not focusing on the design parameters, maybe because you are from the 3rd year and 4th year, so this will be helpful in terms of for the advanced design, right? Advanced design of or advanced water wastewater treatment. So when we talk about the variation of TSS and BOD, there is one study, I mean there are very few studies in terms of understanding that variation in TSS and BOD. So most of the municipal corporations, what we can see that we do not have equalization tank. Why equalization tank is required? What is the importance of the equalization tank? Can anyone? That can be considered as a neutralization tank. What is equalization tank? Okay, so can you see that image? It shows that TSS and BOD concentration are continuously changing, right? So that's the problem. Most of the municipal corporation never focus that the TSS and BOD will be changing. So what happens that if TSS and BOD will be changing, your efficiency of the treatment plant will automatically reduce, right? Because you have designed your treatment plant for a particular TSS and for a particular BOD. Let's say if you have a more TSS, maybe due to rains, maybe due to other activities, right? So the TSS will be more, then the efficiency will automatically get reduced. So that's why we have to provide the equalization tank. But some of the, I mean most of the municipal corporation have not studied in that direction, but right now the new treatment plants that will be having an equalization tank. Although some of the industries, they are having the equalization tank. So you can see there is a figure that shows that 100 units TSS if you are putting, maybe 80 units of TSS you will be getting after the screening tank, then 56 units. So step by step how much amount of maybe the percentage of the TSS can be removed in a treatment plant, that is already visible here. Even if you put 100 units of BOD, at the end you will be getting a 30 units of BOD, right? But it was the earlier thing. Now the parameters have been changed. If you are aware that the disposal parameters, if talk about the BOD, it's between 5 to 10 mg per liter, right? अगर उससे ज़्यादा है तो आप इसको dispose नहीं कर सकते हो. Similarly for the TSS, around 30 to 50 mg per liter we can dispose into the river bodies, right? So again we are not focusing on the design parameters. Let's talk about the pros. So settling of the material by gravity, it reduces the load on the secondary treatment facilities. Cost effective because it does not require more investment in terms of the different what we can say the different technologies. It is more efficient and economical approach to wastewater treatment. And again removal of the suspended solid can be achieved up to 50 to 70%, right? Coming to the cons or maybe a sort of disadvantage, limited removal of dissolved impurities. So we cannot remove the dissolved impurities. For dissolved impurities obviously you have to go for a tertiary treatment. Maybe you can go for a reverse osmosis or ultrafiltration or membrane filtration, right? So that can be utilized for the wastewater treatment plant if you want to reuse or recycle it, right? But otherwise if you are having ROs at your home, please avoid. In Indore, if you are consuming Narmada water, there is no need for putting the ROs for the purification, right? Ultrafiltration or maybe ultraviolet treatment is sufficient so that it can kill the pathogens. Okay, there is also one problem, that limited BOD removal. So BOD removal generally municipal corporation says that we remove up to 80%, but that's not the case. Generally in ASP, that is activated sludge process, we can remove up to 40%. Reliance on gravity settling. Primary treatment relies on the settling of the solids by gravity, which may not be effective in removing finer particles or certain types of pollutants. So this is just a a common treatment method that we have. Okay, there is one secondary treatment. So in IIT Indore we do not have a primary treatment because our BOD is very less, it's almost 90 mg per liter, but when we talk about the urban city, it will be having around 300 mg per liter or more than that, right? And have you heard about the leachate? Do you know the word leachate? Anyone have heard about the leachate? क्या होता है? No. Have you visited any landfill sites in Indore? There is one landfill site in Devgardia, right? Yeah, so if you go there and maybe from soil, if you try to get some, there will be some water at the bottom of the landfill. That water is nothing but the leachate, right? So that leachate is having a BOD of around 1,20,000 or more than that, which is very difficult to treat by activated sludge process, right? So that's again one of the problem, but just I'm just too curious to tell that how the different BODs can affect your treatment efficiencies. So this is one of the treatment unit we are having within IIT Indore, and you can see we have a equalization tank so that whatever the TSS and BOD BOD variations are there, that can be managed. So all these will come first into the equalization tank, then it will be going through the screens, right? From the screens it will be going through the aeration, where again MLSS and MLVSS we have to maintain. I hope you are aware about MLSS and MLVSS. शायद आपने पढ़ा नहीं होगा. Again it is in advanced way. MLSS is mixed liquid suspended solids and mixed liquid volatile suspended solids, which is very important to maintain for the proper effectiveness or for the proper efficiency of the your treatment plant. So after aeration tank, again the water will be going to clarifier. Again clarifier, secondary clarifier है ये whatever the thing you are seeing, it is a secondary clarifier. From the secondary clarifier, again it is going to these pumps, and from these pumps it is going to AGF. We have the activated graded filters and carbon filters. So from after the carbon filter, we are putting that water into hostels, and some of the water is used for the gardening purposes. So we are recycling most of the water generated from our different activities, right? And at the end you will be having a sludge drying bed where the sludge will be mostly stored. But just to tell you that sludge cannot be directly used as a fertilizers. Most of the people, most of the communities, most of the farmers in India, they are directly using as a fertilizer, but that should not be used because it may contain lot of heavy metals, right? And again for heavy metals we need to focus on the different treatments. Maybe we can go for adsorption or maybe another type of technologies. So you can see that organic matter, there is a chemistry involved, that is organic matter plus oxygen plus phosphates plus ammonia that gives rise to new cells, that is helpful for the degradation of the organic matter, and carbon dioxide and H2O, right. So this is how the chemical reaction takes place in the treatment plant. So salient features of ASP, I think no need to focus on when it was developed, but just if you are curious, you can see that it was developed in 1913. So aeration tank is either in completely mixed condition or plug flow condition. So if you want to read more, you can go through this book PV and Howard 1985. It's one of the best book, and if you want to understand the wastewater treatment in a better way, you can focus on Metcalfe and Eddy. हम उसको गीता भी बोलते हैं wastewater treatment की, right? So it's a very good book in terms of understanding how the wastewater treatment plants can be designed. Okay, moving to next. So these are just again some design aspects. I won't be focusing. Okay, so there are problems with the ASP. So there will be always forming of the nocardia foam. It's a sort of foam which is generally formed because of different bacteria called as nocardia species. There are problems with the bulking of the sludge, and again there are different factors like variation in flow rate and pH. So all those different factors generally affect our treatment plant, and ultimately you can see this type of problems comes into existence, right? So we have to focus on the troubleshooting. Most of the municipal corporations, what they are doing, they are focusing on the problems, but they generally do not focus on why these problems are coming, right? So first of all, we have to understand what problem we are having. Either it is a nocardia foam, whether it is a bulking of sludge, and whether it is a rising sludge. So based on that, we have to troubleshoot it. We have to do the maintenance effectively, right? So okay, I won't be focusing on how to do the troubleshooting, but yes, this is how we can do the troubleshooting of the different problems that arises during the treatment. Okay, so most of the municipal treatment plants, they do not have any technology for the removal of the nitrogen or for the phosphorus, right? So that's how this biological nutrient removal comes into existence. This is BNR, and again it is not used for the urban wastewater, because we can say that there is less nitrogen and there is less phosphorus or ammonia or phosphates coming into wastewater. But again, if we want to remove that nitrogen and the phosphorus from the wastewater, then we have to go for a BNR system, that is biological nutrient removal systems, right? So there are various technologies again based on the nitrification and denitrification. So we have Wurman process, Lutzak, Ettinger, and 4-stage Barden-4 process. These are specially designed only for the removal of what you can say the nutrients like nitrogen and phosphorus. Okay, so we have a phosphorus removal, AO, A2O, and phosphate. AO is nothing but the anoxic and oxic. It's a combination of anoxic and oxic. I hope you are aware about the anoxic. What is anoxic? What is meant by anoxic? No, none of you are aware about anoxic. Okay, anoxic is nothing but the absence of oxygen. Also we can call it as a anaerobic, right? So anaerobic and oxic. So if both treatments can be used, we can remove this nitrogen or maybe the phosphorus. So nitrogens, generally what happen in wastewater, what is the form of the nitrogen coming? What is the form of nitrogen? You might have studied in your wastewater course. कौन से फॉर्म में नाइट्रोजन आता है? अमोनिया, राइट? मोस्टली इन द फॉर्म ऑफ अमोनिया. अमोनिया आता है, देन क्या होता है अमोनिया डिग्रेडेशन में क्या होता है उसका? नाइट्राइट्स एंड नाइट्रेट्स क्रिएट होते हैं, राइट? नाइट्राइट्स एंड नाइट्रेट्स. तो जब ये नाइट्राइट्स और नाइट्रेट्स क्रिएट होते हैं और अगर ये नाइट्रेट्स ज़्यादा हो जाता है तो क्या हो जाता है? अगर नाइट्रेट्स ज़्यादा हो जाता है पानी में तो क्या हो जाता है? और अगर आप उस पानी को डिस्पोज कर दो तो व्हाट विल हैपन? What disease will happen? Okay, so you might have heard about the blue baby syndrome, right? So 45 mg per liter से अगर ज़्यादा nitrates अगर पानी में dispose हो रहा है, so immediately it will cause blue baby syndrome. So इसमें क्या होता है शायद आपको पता होगा, oxygen carrying capacity of the child get reduced, right? तो उसका चेहरा पूरा नीला पड़ जाता है. So that is something we have to understand, and most of the urban wastewater treatment plants, we do not focus on the removal of the nitrogen and phosphorus, right? So these are some of the processes. So obviously for developing or for designing those technologies, or not technology, but for designing those treatment plants, we have to focus on the COD by TKN ratio that should be more than 12 to sustain the complete denitrification. So what happens in this process, पानी आ रहा है, एरोबिक रिएक्टर में नाइट्राइट बन रहा है, नाइट्रेट बन रहा है, नाइट्रेट बनने के बाद उसको डायरेक्टली डिस्पोज करने से अच्छा है हम उसको एनॉक्सिक रिएक्टर देंगे, राइट. एनॉक्सिक में क्या होगा, वो डीनाइट्रीफाई होगा और ऑटोमेटिकली वो क्या हो जाएगा, वहाँ पे आपका नाइट्रोजन लिबरेट हो जाएगा, मतलब नाइट्रोजन गैस बन जाएगा और नाइट्रोजन गैस बनने से वो ऑटोमेटिकली एटमॉस्फेयर में चले जाएगा. एनीवे इन एटमॉस्फेयर वी हैव अ 78% ऑफ नाइट्रोजन, राइट. सो दैट इज नॉट अफेक्टिंग आवर एटमॉस्फेयर और अफेक्टिंग आवर सिस्टम. एंड एट द एंड वॉट एवर द इफ्लुएंट विल बी हैविंग, इट विल बी हैविंग अ लेस न्यूट्रिएंट, मतलब लेस नाइट्रोजन रहेगा जो आपको आपके बॉडी को कभी हार्म नहीं करेगा, राइट. सो दैट इज हाउ दिस वुरमैन प्रोसेस इज हेल्पफुल. Now we have a Ludzak, so this is just opposite of that. Sometime what happened, if more nitrogen will be there, it will also affect the secondary clarifier. So हमें वो भी समझना है, इसलिए हमने एक नया, मतलब इन महाशय ने एक नया रिसर्च किया जो है लुड्जैक एटिंगर प्रोसेस बोलते हैं. These are the researchers name. So what he has done, he focused on the anoxic first and the aerobic later, right. So anoxic में first क्या होगा कि आपका जो पहले जो अमोनिया है वो सीधा नाइट्रोजन में कन्वर्ट हो जाएगा, वहाँ से आने के बाद वो नाइट्राइट्स और नाइट्रेट्स क्रिएट करेगा, दैट इज NO2 एंड NO3 एरोबिक रिएक्टर में आपके क्रिएट हो जाएगा. बट अगेन द सेम प्रॉब्लम इज कमिंग दैट इफ यू डिस्पोज मोर नाइट्रेट्स इनटू वाटर बॉडीज इट विल बी हार्मफुल. सो देयर इज अनदर प्रोसेस केम, दैट इज 4-stage Barden-4 process. This is the best process that has been come in terms of the nitrogen removal. You can see that we have a anoxic, aerobic, anoxic and aerobic, right. So these entire systems is helpful for the complete nitrogen removal from the system, that is from the water body, from the wastewater, right. So that is something which is very important to understand for how the nutrient can be removed from the water bodies. Okay, there is another problem of the phosphorus. So again coming to the same point that we do not remove phosphorus from the urban municipal wastewater treatment plants, right. So these are the different types of phosphorus that we can see, that is organic phosphorus and polyphosphates, generally coming from the detergents, or maybe sometime it is also coming from the fertilizer company or fertilizer industries. So obviously those industries have their different wastewater treatment plant, they have separate wastewater treatment plant. But let's say if you are using more detergent, so it will cause formation of the polyphosphates, and ultimately from the polyphosphates it will start scaling on you on the different the pipelines and all the different whatever the instruments that we are using. So again that need to be avoided. So we have a different technologies like we can go for, I mean this is a very common one, ASP, activated sludge process, but we have a different technologies like AO process, anaerobic process and oxic process. So here we are focusing on the anaerobic first and again the aerobic first, but and at the end you will be getting a total phosphorus of 1 ppm, and you can see the inlet parameter should be COD by TP should be more than 40:1, right. So that is the requirement for this process, anaerobic and oxic. And we have another process that is anaerobic A2O, that is anaerobic, anoxic and oxic, right. So anaerobic is completely anaerobic, then anoxic will be focusing on the nitrogen removal as we have seen in the earlier case, and oxic we will be removing the phosphorus. So this is also one of the technology that can be used for the removal of the phosphorus. We have a phosstrip. This is another technology that can be used for the removal of the phosphorus, right. So again we will not going into the depth of how these nutrients can be removed, but yes, it is very important to understand that our urban treatment plants, they are not focusing on the removal of the nitrogen and phosphorus. Maybe there is one reason that we do not have more amount of ammonia or phosphorus coming into our water bodies, right, as compared to whatever the different industries are having, right. Okay, so I think trickling filter, sabne suna hoga, trickling filter, it's a very common one, right, and not used mostly in urban bodies, but let's say if the population is less, if you want to go for a rural areas, you can go for a trickling filter. It is called as attached growth process. So there is a biomass, there is a microorganisms that attach to a particular surface, and it starts degrading the organic matter into water bodies, right. So there are again some design aspects. आपने मीडिया कौन सा सिलेक्ट करना चाहिए, मीडिया, कैन यू अंडरस्टैंड मीडिया, व्हाट इज मीडिया, मीडियम, यस. सो मीडिया इज नथिंग बट ए मीडियम कि जिस पे ऊपर आपका वो बैक्टीरिया ग्रो करेगा, राइट. सो आपने कौन सा करना चाहिए, फिल्टर साइजिंग क्या होनी चाहिए, ऑर्गेनिक लोडिंग OLR कितना होना चाहिए, कितना आप BOD आप उसमें डाल रहे हो, right? So based on that you can design the trickling filter. And there are again some operational challenges like increased growth of filamentous bacteria, again which is very difficult to remove this, and if you are not removing this, again your trickling filter efficiency will automatically get reduced. Clogging of the filter media, there are many chances that your media will get clogged, and again your treatment efficiency will get reduced, right? So these are some of the operational challenges that can be seen in terms of the trickling filter. Okay, so these are, you can see the slime growth over the trickling filter media. So these are the what you can say the media जिसपे एक type का slime growth हुआ है, right? So that again will reduce its efficiency. Okay, coming to the secondary clarifier, already आपको पता है कि most of the removal is occurred in the aeration के बाद जो next unit होता है that is nothing but the secondary clarifier, right? So generally secondary clarifier से पानी आपका most of the पानी आपका साफ हो जाता है, right? I think that is what you might have studied. Okay, but these are again the design parameters. क्या होता है limited flux, underflow flux, we will not going to focus on that. But secondary clarifier, most of the urban wastewater treatment plants में secondary clarifier तक ही होता है, right? If you have you visited any treatment plant in Indore or maybe in other cities? Okay, so आपने कहाँ तक देखा है? Secondary clarifier के आगे भी है कुछ? Okay, so that's what I am saying, that most of the urban wastewater treatment, they generally focus on the ASP, that is activated sludge process, that is the conventional one, and they have the last unit as a secondary treatment plant. Secondary clarifier के बाद generally ये लोग कुछ provide नहीं करते, right? But there is one plant in Pipiliana, if you can visit in Pipiliana, 0.5 MLD treatment होता है वहाँ पे. So they have ozone and they have a disinfection, right? So ozone disinfection they are using for recycling, and ultimately whatever the water they are getting, they are disposing in some lake which is just in front of that particular wastewater treatment plant. So that is also one of the plant we have visited recently for our research purpose. Okay, anyway, moving on further, filtration. So if you want to go for a recycling and reuse, maybe you can also go for a filtration. That's what we are having at IIT Indore. And if once you do the filtration, it can be further utilized for the gardening and the flushing purposes, right? Not for the drinking purposes. ये filtration से आप सिर्फ gardening और flushing purposes और maybe और कुछ छोटे मोटे आप काम कर सकते हो, but you cannot drink it unless and until it can be all the TDS can be removed. That is for that again we have to go for RO or ultra filtration or membrane filtration, right? Okay, so there are different types of filtration. Activated carbon filter, again it depends on the gravity and the pressure. So we have a pressure filters and the gravity filters. Again in gravity we have slow sand gravity filters, we have rapid sand gravity filters, right? You might have studied in the in your third year, right? Okay, coming to membrane filtration, this is the advanced technology like reverse osmosis, membrane filtration, ultra filtration. So we use different membranes to remove most of the dissolved solids. Dissolved solids are nothing but the different salts, like what are the different salts? कौन से salts होते हैं? कौन से minerals होते हैं जिसको आप इससे निकाल सकते हो? तो आपका homework है, ठीक है? So anyway, so membrane filtration and ultra filtration, these generally helpful for the removal of the most of the salts which are having some ions like cations or anions, right? Like sulfates, bromates, iodates, right? So most of those ions can be removed by means of this ultra filtration and micro filtration. Although we will be not focusing on what is ultra filtration, maybe you might have studied in your BTech, right? So these are some of the design parameters. I thought initially that there will be participants from the research background, so I made a PPT in that way, right? Anyway, coming to disinfection, any process to destroy or inactive microbes. So this is again very important. I think one of the student talked about that some of the microorganisms get killed. Some of the beneficial microorganisms also get killed. Yeah, so that get killed, but the biological activities are such a way that most of the microorganisms, because of the presence of the carbon, they will automatically start growing once it goes out of the treatment plant, right? Once it disposed into the river water or the surface water. So that is something is a biological and that is not in our control. So even if we are removing those what you can say the beneficial microorganism, most of the microorganisms will automatically grow, right? Because they get all the nutrients which is required for their cell growth, like a carbon तो automatically available है, easily उनका growth हो जाता है. Carbon is required for the cell growth, right? नाइट्रोजन से उनकी बॉडी में उनका मे बी आप ये बोल सकते हो कि उनका पेट बढ़ता है या फिर उनके मसल्स बिल्ड होते हैं, राइट। हम नाइट्रोजन यूज़ करते हैं, कौन से फॉर्म में यूज़ करते हैं हम नाइट्रोजन, कौन से फॉर्म में यूज़ करते हैं, हम कैसे खाते हैं? जिम में कौन जाता है? जिम में कौन जाता है? जिम में जाता है कोई? ओके, वी आर कंज्यूमिंग प्रोटीन्स, या प्रोटीन इज नथिंग बट अ नाइट्रोजन, ठीक है, वो हम कंज्यूम करते हैं, हमारे मसल ग्रोथ के लिए वो ज़रूरी है, राइट। सो प्रोटीन जब डिग्रेड होता है तब अमोनिया बनता है, अमोनिया हमारे वेस्ट वाटर में जाता है, वेस्ट वाटर से फिर वो नाइट्राइट्स बनता है, नाइट्रेट्स बनता है, एंड देन अल्टीमेटली अगर आप उसको नाइट्रिफिकेशन करोगे तो अल्टीमेटली वो गैस बन के उड़ जाएगा, राइट। सो दिस इज हाउ द साइकिल वर्क्स, ठीक है, उसको जाने के लिए आपको थोड़ा और पढ़ना पड़ेगा। एनीवे, मूविंग टू फर्दर, डिसइंफेक्शन हम जनरली क्लोरीन से करते हैं, और अदरवाइज वी कैन ऑल्सो डू इट बाय मीन्स ऑफ ओजोन, और मे बी वी कैन डू इट बाय मीन्स ऑफ मे बी different methods like chloroforms, right, that can be also used for the disinfection. So there are different methods for which disinfection can be done. So there are design properties, again we'll be not focusing on ideal disinfectant. Okay, so this is another technology, sequential batch reactor. This is advanced, maybe you can say advanced technology for removing most of the pollutants. It operates in cycles, different cycles में ये operate होता है, with each cycle consisting of the different phases, right. These phases include the inflow, aeration to promote biological treatment, settling to allow solids, decanting of the clarified effluent, and idle periods for maintenance and preparation for the next cycle. So this particular technology is very new, although it is being implemented in many of the places, but again still lot of research is still going on the sequential batch reactor, right. So there are some cons and there are some again pros. Like cons is nothing but the high maintenance as compared to ASP, that is activity sludge process. आपको कम मेंटेनेंस रहेगा, बट SBR में आपको बहुत मेंटेनेंस करना पड़ेगा. इनिशियल कॉस्ट इन्वेस्टमेंट विल बी मोर. Skill supervision is required for maintaining or for running this sequential batch reactor plants. Less effective in removing pathogens, again that's a disadvantage, and technical complexity, right. But still IIT Roorkee is one of the institute in India which have installed this particular plant of capacity 3 MLD in September 2019, and at present treating about 2 MLD of sewage. So whatever the treatment going on in IIT Roorkee is based on the sequential batch reactor, right. So they are doing well good in terms of the treatment. So you can see flow is 3 MLD, BOD 200 ppm तक उनका जा रहा है, TSS 407 जा रहा है, TKN 34 जा रहा है, TP 7 mg per liter जा रहा है, right. So BOD 10 mg per liter है, COD 50 mg per liter है, TSS 10 mg per liter है. So you can see drastically reduce 407 से TSS 10 mg per liter पे आ गया, right. Whereas if you talk about the urban that is ASP, maybe you will be not able to see this much amount of reduction in terms of TSS, right. Similarly BOD 200 से सीधा 10 पे आ गया. In most of the part हम 200 से हम 30 या 40 तक लाते हैं in most of the ASP processes, right. So that's something what you can say the advanced technology that we are having in terms of how the different institutes or different organizations are using it. There is another technology, membrane bioreactors. So again these sort of membranes are used in terms of removing the pollutants from the wastewater. So again there are some studies how the Asian countries and Pacific countries are focusing on the implementation of the moving bioreactors, membrane bioreactors. There are some kinetics, we will be not focusing on the kinetics, some fouling, some problems that generally seen in the membrane. And again the same thing, that capex and opex, capital and operational cost will be always more in terms of these ambient technologies. So these maybe you can say these are not meant for the industrial for the Indian cities, right, because it have more capex and opex. So in general India have focused more towards economical treatment, right, cheaper treatment. Okay, so these are some of the plants that still we have 500 KLD membrane bioreactor plant in Delhi. So there is one plant running in terms of understanding whether the MBR are really effective in terms of the treatment or not, right. So these are some of the results from that sample analysis. So BOD COD removal efficiency for this study was 92%. That's very good, right. When you talk about the ASP, we can see that around 80 or maybe less than 80% only we can see in terms of the BOD removal. However, in terms of MBR, we can see that 92% of removal is possible. TSS removal is 93.9%. Nitrogen phosphorus removal efficiency is not so high in the particular plant. The efficiency of treatment plant can be increased in ambient plants with proper monitoring of MLSS, that is mixed liquid suspended solids, which we have to maintain up to 3000 mg per liter in the aeration tank, right? Okay, this is a very new research, MFCs, that is microbial fuel cell technology. IIT Kharagpur are doing lot of research in terms of MFCs. There are few researchers recently focused on the implementation part. Previously it was mostly in the lab, but now they are focusing on the implementation. So again, there are some pros and cons, and this is one of the study you can see in Japan, which have implemented MFCs, microbial fuel cells. So they have installed different capacities of the wastewater to treat swine wastewater. So generally piggery waste से जो wastewater आता है वो उनको उन्होंने treat करने की कोशिश की है. The average COD removal efficiency and coulombic efficiency of the scaled up MFCs were less than those of 1.5 liter MFC. However, the average and maximum volumetric power density of the 100 liter MFC was 0.6 and 2.1. So comparatively, if we see, this is a very new study which has been performed by or studied by various researchers throughout India as well as around the world, right? But again, it's still in the research stage. I won't say that it is the successful unless and until we understand its the efficiency. Okay. Okay, so there are some scaling up challenge. Again, आप काफ़ी research करते हो, but main problem कहाँ आता है उसका scale up करने में, right? Even if in terms of the concrete, in terms of the different studies, whatever you do, maybe you focus on, like I was talking about rubber waste, right? People are using rubber waste in paver blocks. So आप जब research करते हो तो maybe आपको कुछ अच्छे results मिले, but when it comes for the implementation or maybe when it comes for the large scale study, it will be difficult to get the same results. So you have to be very patient in terms of getting those results. So maybe इस time में 4 से 5 साल लग जाते हैं, right? काफ़ी लोगों में उतना patience भी नहीं होता है. Anyway, so this is all about how the research goes on. So there are similar different types of methods, like we have an advanced oxidation process in which the oxidants are used for the removal of the pathogens and for the removal of the different pollutants. So we have a different types of AOPs like hydroxyl radical based AOPs. So these are nothing but the catalyst which helps to enhance the removal mechanism, right? So hydroxyl radical based AOPs, we have a ozone based AOPs. So these are the different oxidants, catalyst oxidants that can be used for the removal of the different pollutants. We have a Fenton AOPs. So there are various such chemicals that are available, right? Yeah, this is one of the study which they are using on a grey water treatment. Can you differentiate between what is grey water and what is black water? Yes, what is grey water?
Domestic waste.
Yes, most of the kitchen or फिर maybe bathrooms, right? Sinks. So ये जो होता है वो grey water होता है. Black water is nothing but the water coming from the excreta, right? So that is the black water. Okay, very good. Okay, so these are some of the studies. Constructed wetlands are the cheapest one. Natural wetlands, I think you might have studied, you might have heard about the constructed wetlands. Now earlier it was on the research, but now various places this has been implemented, right? There is one professor I know, Professor Shyam Asulekar from IIT Bombay. He has done this study on a very large scale in, I think, Sangli or Satara district. Anyone from that particular area? कोई है? नहीं है. ठीक है. Anyway, but you can go through the websites. You will find that they have done at a very large scale, and it has been very what you can say efficient in terms of removal of the BOD, most of the pollutants from the wastewater. But again, there are some limitations with the this type of treatment plant, that it cannot remove all the pollutants which are available in the wastewater. But this is the cheapest one that we can have, because we are not using any big technology in terms of whatever we are having like SBR or MBR or AOPs, right? Okay, so there are some design parameters how this design can be. I think I have copied it. So if anyone wants to know more, they can also go through the this presentation, or they can contact me if they want to know more in terms of this, how the constructed wetlands and all those things are working, right? So this is design of horizontal. So we can go for horizontal flow and we can go for a vertical flow, right? So both ways we can do this type of constructed wetland study. So again, there are some liner materials are required for for this particular wetland bed, so that the water will not leach from the soil to the groundwater, right? So that is again very important. Okay, so there are again cons. initial cost, maintenance, clogging. So initial cost ज़्यादा है, but if you talk about the longer term, it will be less, right? So that's why the constructed wetland technologies are nowadays also used in industries, many industries. Okay, there is USB, ये तो सुना ही होगा शायद काफ़ी लोगों ने, upflow anaerobic sludge blanket. This is again very common, but not used in most of what you can say the urban local treatments. But for the industrial treatments, we can go for USB. USB से generally gas बनता है और gas that can be ultimately used for the different purposes, right? So that is a upflow anaerobic sludge blanket. Okay, so again there are some reactors like sludge bed zone, sludge blanket zone, granular and flocculent zone, and these are some of the design considerations. Okay. Okay, so what we are doing at IIT Indore, what our research group is doing, so we are generally focusing on SDG 6, 7, 11, 12, 13 and 14, and our research is inclined in those SDGs, including the 15, right? So this is one of the study we have conducted recently in Simrol. I hope any one of you are aware about the Simrol, which is just adjacent to the IIT Indore, right? So what we observed that whatever the sewage being generated from that particular area, that is from the rural, because you know they do not have their own treatment plant because it's a rural place. So generally rural में को तो कोई ध्यान देता ही नहीं है, इंदौर में तो सब लोग ध्यान दे रहे हैं. So that's the problem that we have observed, and whatever the sewage is being generated, they are either throwing it on the land, which ultimately causing the land pollution, or either they are throwing it into the water body, which is ultimately causing the pollution to the land, to the water, right? We also collected some data from the nearby lake, and we have observed that the lake is already dead, right? There is no life in the lake. Why? Because they are simply polluting all the water into that particular lake. At the same time, some of the people are also consuming that water for drinking. The lake water they are consuming for drinking, and the lake water also consuming for the irrigation purposes, which is again very challenging because हम वही सब्जी खाते हैं at the end, right? So these are the problems that we are facing in terms of how the Simrol is heading towards the sustainability. So we have done the survey, and what we have observed, there is another problem we have observed besides the sludge, that is the sewage sludge. What observed is the burning of the agriculture residues, right? So they are burning lot of agriculture residues, and you can see if they burn so much amount of residues on a daily basis, around 562.94 kg CO2 equivalent they are ultimately producing, right? So अगर CO2 आप इतना जनरेट करोगे तो क्या होगा? GHG, CO2 is one of the GHG, greenhouse gas. It will cause global warming, it will cause climate change, right? So that's what we have observed, and there are a lot of studies being done in terms of how this global warming can affect our environment, right? So, and on the alternative part, what they are doing, I mean, this is some of the people in Simrol, what they said, that some of the sludge they are also transporting it to the treatment plant. So let's say if they transport 25 kilometer, on a daily basis, so what will be happening? Ultimately, आप fuel को waste कर रहे हो, fuel से again pollution होगा, फिर से greenhouse gas and global warming, right? So this is a waste of maybe the time, waste of money, and affecting the environment. So what we have suggested, okay, this is one of the Pipliana plant that we have visited, 0.5 MLD STP Pipliana, for the same purpose, to understand how our research can be brought to this particular point. So this is a plant process flow diagram. Okay, let's not go into this. So we have done the footprint assessment of the plant. We have understood how this plant is working and how much amount of energy is required in terms of running that plant. So let's say if I will transport that sewage sludge from Simrol to a particular plant, so I will require some energy to run that plant, right? So that is again not good. So that's why we have done the footprint assessment, and we have done some initial characteristics of the sewage sludge. हमने pH, total solids, moisture content, volatile solids, COD, VFA, that is volatile fatty acids. We have checked all those things for the different, and we have come up with the idea that will convert sewage sludge into biogas, right? So we have done some studies at a lab scale. So this is a lab scale study, 1 liter BMP reactors. So BMP is nothing but the biomethane potential. कितना gas produce कर सकता है ना? वो समझने के लिए we have done this study. So हमने अलग अलग variations में हमने sewage sludge और agriculture waste को mix किया in different bottles. At the top you can see there is a brown color liquid. So that is nothing but the sewage sludge, little bit of cow dung, and major proportion of agriculture waste, right? Why cow dung is required? Anyone can tell me? Cow dung हमने क्यों डाला होगा? Just any random thought. ठीक है, एक वो फैक्टर हो सकता है, बट उसका मेजर फैक्टर, मेजर रोल कुछ और है. Very good. So it has essential nutrients that can be helpful to produce a biogas, right? So इसलिए हमने cow dung डाला. Anyway, cow dung is not required all the time, but for the research purpose we have used. Once the bacteria get acclimatized, हमें cow dung डालने की ज़रूरत भी नहीं पड़ेगी, right? But to start, to initiate, we have done that. So there is a blue color liquid that is nothing but the NOH, right? So what happens that pressure is created within that the first reactor, that the top reactor, वो pressure आता है ये blue bottle में, और ये ब्लू बॉटल का जो पानी है, जो NaOH है, वो डिस्प्लेस हो जाता है ये इस नीचे के जार में. सो दैट वे वी कैन अंडरस्टैंड हाउ मच अमाउंट ऑफ बायोगैस इट कैन प्रोड्यूस इफ वी कैन इम्प्लीमेंट एट अ लार्ज स्केल, राइट? यस, बिकॉज NaOH प्रेशर को अच्छे से डिस्प्लेस कर सकता है. अदर केमिकल्स आर ऑल्सो यूज्ड, बट NaOH again we can say that it is based on the research purpose. I mean there are various researchers who have done that in the past, right? हम नए से भी रिसर्च कर सकते हैं, बट अगेन इट विल टेक टाइम मैडम. सो हमें वो टाइम को बचाने के लिए हमें जो पुराने रिसर्चर्स ने यूज़ किया है, हमें उसको यूज़ करके आगे जाना चाहिए. दिस इज हाउ द रिसर्च वर्क्स, राइट? सो NaOH बेसिकली अगर आप देखो तो NaOH ये प्रेशर को अच्छे से डिस्प्लेस कर सकता है, फास्ट डिस्प्लेस कर सकता है. दैट्स वाई वी हैव यूज्ड द NaOH. इट्स एज अ सोल्यूशन फॉर द डिस्प्लेसमेंट मीडियम. सो जितना भी पानी उसमें जमा होगा डेली बेसिस पे, उतना बायोगैस डेली बेसिस पे जनरेट होगा, right? So that is what this study can help you to understand. So these are the some of the results. So we got the peak, I guess, on 16 or 17 day. You can see a peak for the ratio of 2.5. You can see the peak. So this is for the ratio of 2.5, the ratio of the sewage sludge and the agriculture waste. So उस peak पे हमें सबसे ज़्यादा बायोगैस मिला. So that is around something 17 or 18 day. So around 30 दिन लगता है आपको बायोगैस का पूरा मतलब पूरा बायोगैस मिलने के लिए. 30 दिन के बाद ऑटोमेटिकली COD कम हो जाता है, मतलब डिग्रेडेशन पूरा खत्म हो जाता है. सो दैट वे यू कैन से दैट हमें 30 दिन का HRT रख के हमें डेली बेसिस पे हमें वेस्ट डालना चाहिए, राइट? सो अगेन दीज आर सम ऑफ द स्टडीज, विल बी नॉट फोकसिंग ऑन दैट. सो दीज आर द प्रपोज एक्शन एरिया. दिस इज स्टिल वी हैव प्रपोजिंग दैट हम इसको इम्प्लीमेंट करेंगे उसी रूरल एरिया में जहाँ से हमने ये सब कुछ कलेक्ट किया है, राइट? एंड फर्दर वी कैन स्टडी एट अ लार्ज स्केल और एट अ पायलट स्केल कि इसका कितना बायोगैस ओरिजिनली जनरेट हो सकता है, राइट? बिकॉज दैट वी हैव अंडरस्टूड इन टर्म्स ऑफ द लिक्विड, बट इन टर्म्स ऑफ द गैस वी हैव नॉट स्टडीड. सो दैट इज आवर नेक्स्ट टारगेट, right? So these are some of the process flow diagram. We have done some techno-economic assessment. We have understood how much amount of capital investment is required, how much amount of operational amount is required. Total investment कितना लगेगा? So around 2 lakhs, ये तो डॉलर में दिया, but it will be coming around 2 lakhs, right? As a total investment initially. But if you see within 4 to 5 years, this amount will be automatically recovered, right? तो 2-4 साल में आपका ये automatically recovered हो जाएगा और आप अराउंड 4 सिलेंडर का पैसा बचा सकते हो, 4 सिलेंडर, राइट? सो दैट कैन बी सेव्ड इफ़ यू इम्प्लीमेंट दिस टेक्नोलॉजी. सो रूरल लोगों को ये सबसे पहले अवेयर करना पड़ता है एंड देन further if they agree then we can go for the implementation. We cannot randomly go and we cannot implement, right? We have some limitations of IIT itself, but yes, they can save up to 4 cylinders. So एक सिलेंडर अराउंड 29 kg का सिलेंडर हमने निकाला है. अगर 29 kg का आप सिलेंडर यूज़ करते हो विच इज़ द मैक्सिमम कैपेसिटी ऑफ द सिलेंडर, तो 4 सिलेंडर आप सेव कर सकते हो, राइट? सो आप उसको कैलकुलेट करो इन टर्म्स ऑफ द मनी, राइट? कि एक 29 kg का कितना होता है. जो हमारे घर में 16 kg का होता है वो अराउंड 1100 रुपये का होता है, राइट? सो दैट वे अराउंड 2200-2300 का होगा, राइट? सो दैट वे यू कैन सेव अराउंड 10,000 रुपीज़, ठीक है? Okay, so I think I will stop here. There are a lot of things can be discussed. This is one of the study that we have done in our campus, again constructed wetland. So you people can also, those who are in 3rd year, they will be going in the final in next year. You can also focus on those small treatment methods. This is a constructed wetland. We have designed this for the removal of the pollutants in a vertical flow. We have used this species which is available with our institute itself. And we tried to remove the parameters. So you can see this was the initial grey water and this is the final grey water, right? So that can be done at a small scale. आप research के purpose से आप आपके institute में कर सकते हो. आपको कोई help चाहिए तो I will be always there for the help, right? Yeah, so I think I will stop here. So thank you so much. I would like to thank the committee, the organizers, the coordinators, even DST SERB, and I appreciate that IPS are getting so much funds from the DST, and they are struggling hard, and I am really happy to see that you have patiently listened everything, and also it was really interactive. अगर कुछ भी आपको हेल्प चाहिए, so we'll be always there to help you, because our task is to help the students. So you may email me on mayur.jain@iiti.ac.in. So we have a huge group of in terms of the research. So you can see these are the group members, those who are working with me. We are working on various topics like waste to energy, rapid composting techniques, thermal treatment. So we have also started focusing on the biochar. I hope आपको पता होगा biochar, but anyway, if you want more detail, you can contact me. Circular economy, we are also focusing on some small studies on the green building assessment, techno-economic analysis of solid waste management systems. These are mostly BTech students. There is one PhD student, and these are some interns, those who are working with me, right? So thank you so much once again. If you have any questions, you can ask me. Yes.
So the areas which are near the nuclear power plant, is there any possibility that there is some radioactive substances?
Yes, definitely. Definitely, there are full possibilities that the radiations will be there. But right now, I mean, I met one of the professor from the BARC, Bhava Atomic Research Center, Mumbai. So they said that that's why they keep their area far away from the city, and at the same time in the proximate area they won't have any residential activities going on. But again, there are some roads going, and people will be moving through that area. So obviously there are more chances of the radiation will be there.
So is there any way that we can find that whether the substance is present in
Yeah, we can find by doing some maybe you can see high volume samplers that cannot be used, but there are some technologies that can be utilized in terms of understanding कि air में कितना radiation जा रहा है. That can be done. वो सभी उन्हीं के पास है, but वो बताएंगे नहीं और वो किसी को काम करने नहीं देंगे.
So is there any link between the air pollution and water pollution?
Obviously.
So the air.
What are the different pollutants going in the air? Ultimately, it is depositing into your water bodies by means of rain. So whatever, let's say, the SOx, NOx, all coming due to the deposition of rains. Ultimately, water से वो जो pollutants है वो crops consume कर लेते हैं और crops को हम खाते हैं. So there are always chances of that.
Thank you, sir.
Yeah. Anyone else?
Sir, what is the percentage of inorganic solid output from sewage and STPs?
Sewage sludge में inorganic का percent. Okay. So see mostly sewage sludge में inorganics क्या होता है? क्या होता है inorganics? Mostly silt, sand, है ना? Gravels, यही inorganic होता है. So most of, if you say around 70% तो organic ही होता है, 30% inorganic होता है. But again it depends on the different areas, है ना? अगर वो पानी आपका surface runoff को लेके आ रहा है, तो maybe you can see that inorganics will be more. So that's what I initially said to you, that it depends on, everything depends on from where the water is coming. अगर आपको source पता चल गया ना, so you will be able to design a efficient treatment plant. But the major problem is that municipal corporations कभी industries के साथ collaborate करते नहीं, industries कभी academicians के साथ collaborate करते नहीं, और academicians like IITs never go to municipal. So that's the problem in India, right? However, if you go to other countries, you won't find those problems because they are collaborating with each other, है ना? तो आपको mainly source पता होना चाहिए. You will be able to design a proper way, right?
Thank you, sir.
और कोई? Okay, so then thank you so much. Thank you, Lalitesh ji. I think he was coordinating with me all the time, and thank you for the hospitality. The car was really nice. Okay, so thank you so much. Yes.
So can we have your PPT?
Yeah, I think it has been copied. Yeah, it has been already copied. Although there are some data which need to be, which not yet published.
Thank you, sir. It was wonderful.